Welcome back, dear friends, to another exciting episode. Now, last time I finished all the heraldic Clarendor horns and gave you the warning, that's right, about Etsy. If you buy something on Etsy and you see an advert for a lovely item made by some individual somewhere on a platform other than Etsy, such as Google or appearing somewhere, don't click on the link. If you click on the link, that person will be charged about 30% commission, which is an absolute joke. Instead, find Etsy, Google Etsy or whatever, go to the Etsy website and then find that person on the Etsy website. That way they will be charged about 10%, which makes a huge difference. Anyway, no more on that. Stop it. I have two choices now. They're the same two choices that I've had before. I managed to avoid. I can't avoid them this time. I've got to make a decision. Either, yes, it's the Clockwork Unplanned Steampunk Penny Arcade machine. Oh dear. The story behind this is, and I'll put a link to the playlist, I thought it would be fun to build one that didn't use any motive power, like electrotrickery or anything, other than the weight or the potential energy, and you see that in there, when you lift up a big lead weight. You lift it up, and it'll only allow you to lift it up once you've put a coin in the slot. And then all sorts of... I thought I'd just start by simply making the sort of game management mechanism. You put the coin in, you can have a play. If the ball goes out of play, you can't re-go, and if the ball lands in another one of these, a front one or something, then you can lift it up again and continue, and there's the scoring system, and it was so complicated. What you could have done in about 3 or 4 lines of Arduino code, it took me ages to do. And then I ran out of steam, literally, actually. Other things came along and I was absolutely thrilled, because every single part of this machine took about 3 or 4 goes to get it right to work, because, as I say, I'm not relying on electricity, which is so much simpler to use. So the next thing I need to do is to work out the actual gameplay. The ball is delivered about there, which I realised was quite large. It's about there, so I needed somewhere to flick it to the top. So I did actually start thinking about this and came up with a couple of ideas. Ball release there. I've taken some measurements and things, so I know roughly where everything is happening. Ball comes in there, flipper here, sort of curved top, because obviously this game, actually it's not obvious at all, this game works by keeping, the score continues to go up the longer the ball is in play. So if you're hopeless and the ball goes out of play immediately, you've got a very, very low score. If you keep managing to lift it back up when it reaches the right bit of the bottom, you can keep it going, and then the score will go up and up. So every part of this must not allow the person to trap the ball, because if you think about flippers on a pinball machine, you can sort of flip them up and the ball can just sit there for ages, and then you let it roll down slowly. Mustn't do that, so I thought I'd have a slight angle on this flipper, so you've got to do it really quickly, otherwise the ball will just roll off. And then this brings me on to my next idea, which was to have a tube running across the top, preferably dark blue, with moons and stars and suns and things on it. Well, stars and suns, moons or something. It'll have a slightly conical inside, so the ball comes in this end and it rolls down always. You can't stop it doing that. And then you can rotate this to try and get the ball to go through the hole that you want. So that's as far as I've got. And I thought, well, you couldn't see where the ball is in this. It disappears in one end and you might catch glimpses of it through holes. Stupid idea. And I thought, well, have a half one and have a mirror above it. You'd have a semicircular one, mirror above it, so you can see where the ball is, and then you can just twist this backwards and forwards and work out bearings and things. And that's as far as I got. Yes. So the second option, which I'm erring on, or towards, is the Art Deco Clock that I've mentioned before as well. I made this out of MDF probably about 30 years ago. and never got, well, in those days, they didn't have the sort of technology available to easily make a day, date and month display. But they have got that technology now, and I'm really keen to get this finished. Ideally, I want to learn how to mould this out of, I don't know, something like fiberglass. It's a bit big for a vacuum forming. Anyway, come on, more on that later. But I really want to get this done after 30 years. Now, why start with the clock dial? It's relatively simple. When you can start with the day, date and month. Because we now, almost at our fingertips, have e-paper or e-ink, which is amazing stuff. If you've seen a Kindle, I remember seeing Kindles and thinking, how on earth did they manage to achieve that display? Very low power, and it looks really just like paper. And the way it does it is very much like the magnetic play strip that I used for the Gregorian scribulator. That uses magnets. If you put a magnet on one side, it pulls lots of little black iron filings through some thick viscous liquid that's white, opaque, to the back, and you can't see them anymore. If you put a magnet at the front, it pulls them all to the front, and then you can see them and they appear black, and they've in lots and lots of little cells to stop, well, to keep the iron filings, you know, scattered randomly around in the right sort of proportion. So that's that. E-paper, or e-ink, or whatever, that works on a much, much smaller level, and it uses the same principle of little coloured particles in a white liquid, but they're moved by electrostatic charge that is applied to a network of cables, wires or whatever, and then they pull the little particles forward and you can see them, or they pull them to the back. Isn't that amazing? Progress for you, from a child's toy to a Kindle. And it's great because you can now get them for hobby things. Thankfully, my very kind long-time follower and supporter, Ibrahim, he actually sent me some money to Amazon so I could buy one of these, and he recommended which one I should get. And this is a 2.9-inch e-paper module. So I am going to start today by wiring this up, following the instructions, and seeing if I can get it to display something. I really want to understand how these work, because it's one of those things, there's so much potential. Literally, actually, electrostatic. I thank you very much. Here's the laptop with the Wikipedia copy of the web page on, because this is my lovely old computer. I can't connect to the internet anymore, but mustn't grumble. So I've saved up the web page. I've got the instructions. I've got the lovely module. Ooh, shiny whiteness. And it looks like, well, it comes with a lead that plugs in there, and it tells you what pins to connect to which connections on an Arduino. And the wiki web page also covers using it with all sorts of different things. There's a big list down the side, all sorts of different processors. So I'm going to get this plugged in and upload the example sketch that it's got a link to, and I'll get back to you, as it's so nice to share failure. So I've extracted from the zip file that it came with, the instructions, the sketch, which includes all sorts of fonts and other pieces of information that it all finds in the unzipped folder, so that's exciting. You can see probably here that I'm putting off the inevitable. Wretched subscription alert. I'd love to plug it in and get it all updated. Anyway, so I've uploaded that to the Arduino. I've connected these to the right things. I suppose it draws such little current that it can all run off the power supply that's in the Arduino. So now I'm going to plug that. Now let's see what happens. I have no idea what I'm doing. I've tried to have a look at some of the sketch. It doesn't make any sense to me. Right, let's plug that in. Ooh, ooh, it did something. Ooh, ooh, ooh. How exciting! And that flickering on and off is basically, apparently, to get rid of any charges on the little particles, because otherwise they can end up sticking and your display can start having sort of ghosted images that you can't get rid of. So it has to sort of shake it, I suppose, a bit like shaking it, to force all the little particles to the right bit. It's lovely when something actually does something, and isn't that a beautifully crisp display? It really does look like a printed image. Well, that's been most educational. I've learnt a lot, because it proves that it would be possible to use e-paper or e-ink running from an Arduino within this. Now, I mean, it's stupid, isn't it? 30 years in the making. That's fine for that one, which I think I must have intended to be day. Date, fine. Month is too short, it's too narrow. What was I saying when I was so rudely interrupted? Yes, that won't even magnify it, not with the depth here. I know this is all getting a bit crazy, because I don't need to do. I could design a new one that's smaller, more manageable to copy or make or manufacture, that these would fit in. The other great thing about e-paper is, obviously, you don't need any electricity. Once you've arranged the little particulates, you can, in effect, switch it off or send it to sleep. The example is interesting. I've been studying it a little bit. There's loads across the top. There's loads and loads of extra files that it's added, libraries, font definitions, all sorts of stuff. And then it includes some extra libraries here to enable it to draw onto the e-ink paper thing, whatever. It's several days later, and the frustration is telling. It happens every time. Every time I have to work out, learn new stuff. It's a very frustrating process. I worked out and discovered that because of the number of pixels in e-paper, e-ink, it's just far too many for something like a microcontroller like an Arduino, or apparently most microcontrollers, to actually store have enough memory, RAM, to be able to create a full image and then to upload it to the e-ink in one go. They can't do it, there's not enough. For example, the Arduino Uno has 2K of RAM. I think it's 32K of program memory that can be used when you upload your sketch, that contains fixed information that can be read, but only 2K of RAM that the Arduino can use when it's actually running your program, your sketch. It's not very much, it tells you. It reminds me of the Spectrum and the ZX81. But they didn't have 32K to store all this other stuff in. So, to cut a long story short, what you have to do is you can only write, you create an object or an array, and in most cases it's about 1024 characters long. And into that, you call it paint, a paint area, a variable in effect. You can draw also, you can tell it how big, what sort of shape it is, but it can't be any bigger than 1024 bytes. It's not that big really. So once you've told it what diameter, once you've told it what dimensions you want this paint variable to be, then you can draw rectangles, circles, lines. You can write text into it or single characters, all sorts of things. And then you upload that to the memory in effect that's in the e-ink, I think I'm going to call it e-paper, it makes more sense, into the e-paper. And you do that over and over and over again, and the e-paper doesn't change or anything, but you can just slowly build up, and if you overlap these paint areas, then whatever's underneath will be hidden. You can't have any transparency or anything, as I've discovered. So you just build up your image, and then once you've got it all done, all ready, then you tell the e-paper to actually upload that to its screen. And that's when it flickers on and off and puts the new image up. I've also been experimenting with different fonts. This one, which I found first of all, looking wonderful, downloaded that. I don't like that O. Whereas there was a free copy of a different font. This one's called Opticaling Light. And I do like that. I do like that a lot. I thought the next thing, before walking the dog, scratching my head some more, would be to actually look at a font and see if I could work out how I can construct it from shapes and things with lots of straight lines. It's the curves that are the problem though. Time to take the dog for a walk. Let's see how she's doing. There she is. It's another very hot day. Tile's going, lovely. Do you want to walk, Ziggy? Come on then. It is true. It's walk time. Come on. Let's see what effect this has. You didn't need telling twice, did you? No. It is that time again. Yes. Please forgive the rambling nature of this video. I keep coming up with new ideas. How I'm going to edit it all together, I have absolutely no idea. But having returned from the walk with the dog, that's the right way round, I came up with a cunning plan, I think. I've yet to try it. Let me show you. So my plan is, within the paint area, so it doesn't exceed the memory, I'm going to test it, but I think you can draw rectangles, lines and circles. As many as you want, overlapping, whatever. I think, as I said, I've got to check that. If that's the case, and if you've got an H, which of course is the one letter that I'm not going to need, just for illustrative purposes though, 3 rectangles, and you can have the rectangles filled. This one, if you've got an A, if I can get it to draw quadrilaterals, I have to write that down to remind myself, filled quadrilaterals, which it doesn't come with a command to do, but hopefully that'll be possible using lots of lines. Then you see 1 quadrilateral, 2 quadrilaterals, 3 quadrilaterals, and I've made an A. And I was thinking, well, curves, this is a problem with straight lines. But there we are, quadrilateral, 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 loads of circles. Because each time you write one of these or draw the item, the graphic, onto the paint area, then all the memory's freed up. It's just a few more pixels or whatever, memory points set, so you can just keep doing it as many circles as you like. So that is a cunning plan. Now that plan would require me to spend hours hunched over a hot computer using 2D design CAD software to look at each letter and to recreate it sort of by drawing over it with a mixture of circles and things and recording all of the coordinates. But what a lovely job. Look, I've done a thing, a useful thing. That's amazing. As always, when you have learnt something, you look back and you think, I don't know why it wasn't, I never understood that. This is early days though. All I've done is to manage to draw a rectangle in each corner of the display. Also worked out with a 90-degree rotation on that paint thing is Y up and X across. That makes perfect sense, and 0, 0 there. Is to draw a rectangle 23 by 23 in the paint area and then move it, and draw it 4 times and move it into the different corner. And it's odd, isn't it? This is the sort of thing that takes all the time up, because X, Y, these are the coordinates as you'd expect for the rectangle, but then when you put it on the screen it's Y, X. Oh, the joys of working that out, but I have worked it out now. So the next thing to do is to try and work out how to create, what was it called? A quadrilateral. That's right, from lots and lots of straight lines, because I don't even need to have lines around the outside. I just need to have them, lots of horizontal lines inside. How exciting. Heavens to Betsy. I just wanted to work out and draw the maximum paint area that you can have for 1024 bytes. Just out of interest, just to sort of get my head around it. So, but that's interesting. And I've also learnt that the paint area is not like the e-ink area. There's the e-ink area, X, Y. The paint area, the origin is up on the top left. So that's very handy to have learned that. I've just figured out something else as well. It's the gift that keeps on giving. When you draw the shape, it doesn't matter what you're doing or what rotation you've got, the width of the paint area is as if the board is that way up. Assume that's how they're manufactured to be used, and the height is that way. So, because you think, here we are, look, change the shape of my paint area, width, height. It's not. The width is the height and the height is the width, and this doesn't have any effect at all that I can see. The latest breaking news, I've discovered that drawline cannot draw a vertical or horizontal line. It should be draw diagonal. If you make it diagonal, it does sort of other strange things. I'm like, oh, I can see why so few people have actually written about e-ink and stuff. It is so difficult. Aha, so you can draw vertical lines, but you have to draw them with the rectangle tool. Excellent. This could well send me round the bend. I knew there was a reason I keep persisting. The joy when you finally get something to work, however small, it still works. Now I reckon I'm going to stick with what they called again, quadrilaterals. But I'm going to cheat a bit and have them always parallel, or whatever. But so you can angle them over. So I've just written. Oh, it's such a joy to writing 4 statements and things. Think I sorted out the maths. Don't know why. I think I just prefer it. It's more natural to write it on paper. Then I wrote it on here and I fiddled around with it a little bit, adding some floats because there are some fractions, whatever they're called. Then look. Oh, I can't tell you the joy. I've managed to create a bigger shape on there. One that I'd planned myself with numbers. Excellent. And yet again it's time to take the dog for a walk. I wonder what ideas I'll come up with this time. Just before I take the dog out, I remembered that the whole point of this was to be able to compress all the information needed to draw fonts to a very, very small size using vector graphics rather than bitmap graphics. So I've just done the maths, or math. So, calculating this area, that rectangle, or whatever it's called, is 2,500 pixels. I defined it using 5 integers, each which takes 2 bytes. That means there's 10 bytes, 8 bits in each byte, so that's 80 bits. So I've managed to reduce 2,500 pixels to 80. I think we're on to a winner. Calling me old-fashioned. Thanks very much for watching. If you still are, well done for making it to the end of this video. It really has been such an uphill struggle. Old dog, new tricks and all the rest of it. But I'm getting there slowly. Next time I can't wait to draw out everything on 2D design, plus the lettering, and to try and model each letter with rectangles and quadrangles. That's it, I've remembered. And circles. We'll see how that goes. Thanks again.